Alright, today we are doing square root function transformations. We've done all this before. The last 2 days we've done inverses. Where we've done inverses before, they're just square root and cube root. Today and tomorrow, what do you think we'll do? Square root and cube root transformations. We've done transformations before. That's where we say left 6, down 8, reflection over x, stuff like that. So we see the formula f of x equals a is on the outside, then the square root of x minus h, and then on the outside plus k. It's all the same letters, A, H, and K. Those should look familiar. It's just written in a different type of formula. All right, and then it says H is the horizontal shift plus shifts left. Remember, anything inside tells a lie. I used to say inside parentheses, but think about it inside anything, because this isn't parentheses. Anything inside tells a lie. So if this is x minus 4, instead of left 4, remember, you're actually going right 4, because it's under something. It's inside something. So as you can see, it says a plus shifts left, a minus shifts right. So it's the opposite of what you think. Inside tells a lie. K on the outside is a vertical shift. We should know that. So a plus, because it's outside, it tells the truth. Plus, you're going up. Minus, you're going down. The end point of the square root function is hk. Remember, we should know already from our graphs, when we graph them, that square root look kind of weird. It's like that. Okay, it's not a full parabola, it's not a line, it's literally written or drawn out like that. Okay, so the end point here is whatever h comma k is. Okay, then if a is negative, the function is reflected across the x-axis. So if this would be -2, it's reflected across the x-axis. Then if a is greater than 1, it's a vertical stretch. But if a is between 0 and 1, it's a vertical compression. So if a is 2, you would say vertical stretch by 2. We know that. If a is 1/2 or 1/3, then we would say it's a vertical compression by 1/2 or by 1/3. Again, this should all sound familiar. Literally, the only difference is how the graph will look, and that it's a square root. So we look at number 1 down here. We see it has x, the square root of x minus 7, and then on the outside plus 2. So it's as simple as this inside, it's left or right. So we know it'll be 7, and because inside tells a lie, it has minus, so you would think left, but it's really right 7. So you write right 7. Okay? Then on the outside, there's that plus 2. That tells the truth. So plus means up for the outside, up 2. And we're done. That's it. All right. Then we see number 2. Number 2 has 4 on the outside, then square root of x minus 1. That 4, we know that's a vertical stretch by 4. Remember, where a is, which is on the outside before the square root, if it's greater than 1, it's a stretch, so vertical stretch by 4. If that had been 1/2, then it would be a compression, but because it's greater than 1, it's a vertical stretch. And then finally, that minus 1 on the outside, it'll be down 1. Don't forget, inside inside the square root, inside the parentheses, that's always left or right. Outside, that's up or down, and it tells the truth. So minus 1 is down 1. All right. Finally, let's do the last one. This is going to be a short video, less than 5 minutes. We have f of x equals negative x, the square root of x plus 3. So the first one, we see this negative. So it's going to be reflect across x-axis. So reflect across x-axis. And then we see that plus 3 inside, so it tells a lie. So it's really going to be left 3. All right, because this x plus 3 inside the square root tells a lie. So instead of right 3, it's actually left 3. And that's it. Because of that minus on the outside, reflect across x. And then inside the parentheses is x plus 3, so you'll go left 3. And that's it for transformations. It should be pretty easy. Complete the worksheet, turn it in.